Welcome to the Risk Awareness Week 2020 and my presentation, How to Use Value of Information to Improve the Decision Policy in Oil and Gas. My name is Trügvе Ботн. I'm a decision consultant at ThinQ Decisions, a consulting firm that provides strategic decision-making support to clients when faced with risks and uncertainties. I hope you enjoyed this presentation. I look forward to chat with you afterwards. The objectives for this talk is to explore how continuous variables improves decision policy. You will also learn how to model a value of information problem using SIPMAT. So I divided this talk into two parts. First, we're going to talk about the fundamentals of VOI before we go into a case study with subject matter expert. In this case study, we frame an oil drilling and development problem and further incorporate that frame into a risk model in Excel. We will then analyze and evaluate the problem with the help of the subject matter expert before reviewing and explaining the results at the end. So what is value of information? So to me, this is a quantitative approach used to mitigate risk where we assess the value of obtaining additional information before making a decision. So let's look at an example here. So this individual has an option to buy a used car for $35,000 with the uncertainty around some future repair cost. Or he can choose to buy a new car for $39,000. Let's further assume that he has done some sort of assessment that would indicate that the repair cost on this used car may be anywhere between $15,000 and $0. So if this individual then had some sort of information that would inform him the condition of this used car before he made his decision, that would greatly impact the value or the cost he would pay for this vehicle. So for instance, in this example, what if he was able to pay a mechanic to inspect the used car before deciding? So if this inspection report maybe informed him that the car was in poor condition, he may be changing his decision from buying this used car to a new one. So when we talk about the value of information, there is a value in this individual's opportunity to change the decision based on the information he's purchasing. VOI is then calculated by the value of the optimal decision policy with additional information minus the value of the optimal decision policy with no additional information. So some of the VOI terms I will be using in the presentation is worth going through. So asset decision, the decision with the potential to change. So in the car example, that's the decision where this individual is able to change the decision between a new or used car. Then we have something called reality uncertainty. So this is the uncertainty that if a result could impact our choices. And this is based on the current perception of reality with the current information we have available. This current perception of reality needs to remain fixed throughout the VOI study and cannot change. So the information decision is then the decision to obtain information or not, or what type of information to obtain. If we choose to obtain information, well, this additional information may have some ability to inform us about the reality uncertainty. So there's a dependency here around the information uncertainty and the reality uncertainty. So let's look at the background for the case study we have. So there's an oil company called Polar Oil that's made a discovery in the North Sea. So they have already drilled one exploration well in the south and one appraisal well also in the south. So they're now considering drilling a third well in the north before they decide on a potential development. So there's some agreement internally that they will take a core sample during their appraisal well in the north, but there's also some interest from the internal facility manager for a production test being done in the north when they're drilling this appraisal well. The subsurface team has divided the resource uncertainty into 4 different scenarios and called them minor, small, mid, and large, with associated probability of 40%, 10, 35, and 15. There's some general uncertainties here, price of oil and development cost. And then also, if they choose to exit the resource opportunity now, it creates a bad company reputation, but at no cost. So the risk of value erosion here is if Polar Oil develops this oil field with low resources, cost being very high, or the oil price being low. So before we go further, let's just review an important concept around VOI. So reliability of information is very relevant when it comes to imperfect information. So typically we do an assessment beforehand where we move the reality uncertainty in front of the information node when we do the assessment with the subject matter expert. So in this case, we're asking if the repair cost in reality is high, what is the accuracy of this test? And in the case of the car example we had, in this case, if the repair cost is high, the test or inspection report will recognize it's high 90% of the time. So you see it's not perfect. So 10% of the time, the report will indicate that it's in mid condition, and 3% of the time, it will indicate it's in low condition. The same thing happens in the low case. When the repair cost is actually low, we see the same accuracy of the test. In the mid case here, we see that the reliability or the accuracy of the test is even weaker. So 60% of the time, the test will truly recognize that the repair cost in reality is mid. But the other 40, it will give us some false indication. In the case we will do with ZipMat, we will use a similar approach, but we'll use a matrix instead that will read the same type of reliabilities as we have here. So once we have done the assessment, we are ready to do the evaluation or the Bayesian flip. And here we have put the information node in front of the reality and calculate the associated probabilities. So for the high, for instance, we will have the joint probability of high, mid-high, and low-high. Will give us 18% in this case. And further, we will calculate the conditional probabilities for the repair cost. So how can VOI add value to a decision? I'd like to pinpoint 3 things here. So first is, it establishes if the information adds value. This is relevant to us because it improves our capital efficiency. So obtaining information is not always equal to value. So remember in the car example, if you never have the potential to change a decision, obtaining information is not adding any value to you. So if you're always going to do the same thing, buying more information is just going to incur more cost to your project or investment. The next thing is determine how much information is actually worth. So this can help guide us so we don't pay more than we should for the information that we consider paying for or obtaining. And lastly, we need to understand if the information has the potential to change the decision. And this improves our understanding of decision choices, the consequences, and the risk that's associated with the investment. So application of VOI is not just for oil and gas. There's a lot of different industries and business segments that could have use of VOI. And this is done today for a lot of different reasons within the medical and healthcare. So we have pharma companies that evaluate reliability of the COVID test, sensitivity and specificity. We have them go through preclinical and clinical trials and R&D development for drugs. Marketing and sales is another example here. So conduct market survey before launching a new product. Energy, pilot testing and R&D of a renewable technology before commercialization. And construction, mitigation of cost and schedule risk during execution. What's the value of doing that study beforehand? So you see, VOI is very applicable to many different problems and businesses. So what we have traditionally looked at when it comes to VOI is to have a discrete approach to coming up with the expected value VOI. What we will do in this case is to focus on the latter part here, which is the VOI distribution. So with ZipMat, we can generate this fairly easily, and I'll go through that in the next steps. So let's get back to the case study and explore a little bit more around the resource scenarios we have. So the subsurface group has divided the uncertainties into 2 parts. The certainties that could be observed and learned from by drilling in a well, and some unresolvable uncertainty, the remaining uncertainties. So further, there's a high and low resource case that can be seen by the green and the red outline here. So for the minor scenario, we will experience a fault. There's no reservoir in the north, and we'll see low permeability. In the small scenario, there's still a fault present, but now we have a small reservoir in the north. and we still experience low permeability. The mid scenario has no fault, and there's a reservoir in the north that's partly connected to the south. We now experience mid permeability. In the large scenario, there's no fault, and the reservoir is now fully connected, and we experience high permeability. So to summarize the frame, we have found three different decisions. Should we develop the oil field? The asset decision, which is a yes or no. Should we obtain additional information before deciding on the development? What type of information should we acquire? So you remember from the background of the case study, we could then do a core study, or we can do also a production test. So we will look at both of those information sources. The uncertainties we have is the resource volumes, the oil price, development cost, and the cost of information. The risk here is the suboptimal development due to low resources, high capital investments, or low oil price. So let's go over to Excel and incorporate the frame and meet the subject matter expert. So we're here ready with the model to incorporate the frame that we just did for our case. And with me, I have the subject matter expert, and I'll let her introduce herself.
Hello, everyone. My name is Elizabeth Buhai, and I'm the reservoir advisor for Polar Oil.
So Elizabeth is going to help us along here, and also she will have the decision authority for the decision policies that we come up with. So before we get started, let me just briefly go over the structure of the model so you're a little bit more familiar with the different sections. So up here, we'll have the results section. We'll store some of the charts we see, and also I will save the cases we come up with here. In this section is the calculation engine. Here, one trial out of 1,000 that I will use for the simulation here will be presented. So bear that in mind when you see a number here, that this is just one trial out of 1,000. This section consists of the decision to develop the field or not. It has the resources that's using the probabilities for the different scenarios down below. And it has the revenue part here. So the revenue is calculated simply by taking the resources times the oil price whenever we develop. The cost section is then following the same structure. It takes the development cost whenever we develop the asset. It also have a line here for the information when we're going to look at different appraisal well information sources. The total cost here sums up the cost, and then the economics are then calculated simply by taking the revenues minus the cost. So a very simplified model. Down here we have the decisions. So the first one is the asset decision, where we have the choice to develop or not develop. Then we have the information decision here, that we're going to populate as we go. And this part here, I'll come back to when we go into the value of information part. Here we have all the uncertainties that we had in the frame. So we had the development cost, the oil price, and then the 4 different resource scenarios here. I also have a section for later where we're going to capture the cost ranges for the appraisal well. In this section here, I'm simply sampling using a uniform distribution what resource scenario the reality is on. So here I'm capturing just the random number and then matching it with the cumulative probability to give me, in this case, mid resource scenario. So with this, the first thing we want to do is to then now develop the economics with no further information. So there's 2 options. We can develop the field with no further information or walk away. So the first thing I'll do here is then to reflect the inputs we have for the different uncertainties. And I'm using a triangle distribution for this. I have also developed a sum of the different scenarios here. So we can look at that as we go as well. So at this point, we can go up and maybe calculate the economics.
But before we do that, is there any way we could plot the graph to show the resource scenarios?
Sure, we can do that. So a good way, maybe that's a good point here. So maybe we plot Yeah, we can plot all of these and then maybe overlap so we can compare them.
Okay.
So we already have some names for that. So what I'll do, I go define the outputs here and then select those. And then I will graph these. Okay, so Elizabeth, as you can see here, we plotted the resource scenarios. And one thing I want to mention here is that if you look at the curves, they are not 4 separate curves. So they are slightly overlapping a little bit. So you see the gray here is overlapping here with the tail end of the mid case, the yellow, and this one, the mid overlapping here with the large, and so on.
Okay.
I also want to point out that I have done this, taken the sum of the 4 scenarios and represent that in the black line with those associated probabilities of each scenario. So now let's go and plot the economic results. So Elizabeth, now we have developed the distribution of developing this asset with no further information.
Okay. Gosh, I knew that development was challenging, but I didn't think it was this risky. Is there any way that I could see the resource scenarios plotted on the graph on the left-hand side so that I know where each one falls?
Yeah, that's actually a good point. So let's try and I think we can actually easily do that because we already set up some of the development scenarios here. So
Okay.
this section here has the different scenarios, but we have a formula here that takes it only when they develop.
Okay.
So since we're always developing now, they will be easy to plot. So let's just do that. So Elizabeth, here is now the different economics for the different scenarios. Okay. So you can see here the orange is then the minor and so on. So what you will see here is that if we end up with a minor resource scenario, we're almost all negative. There's a slight positive here that I suspect come from very high oil price combined with very low development capex. The same thing is true for the mid case here, where we have fairly negative. I mean, there's 60% chance of being negative, but you also have a little bit of negative into the downside here on the mid and large scenarios as well. So those combined with the cost and the price contributes to the downside we see here, but it's still a fair bit of upside in the decision.
Right. Okay.
So based on this, I'm not sure how do you view this in terms of deciding on the decision policy?
I mean, like I said, it's a challenging development, but we understand the risks here. And I believe our management team would still like to look at developing this asset. We want to make sure that we're in a good position to capture resource opportunities in the future. So let's go ahead and looking at developing. Okay.
So what I will do is, for now, let's capture the expected value for this node development. We'll call this the reference case. So the expected value here is 33 million. So what I'll do, I'll clean up the chart a little bit and we'll go back in and look into perfect information. So before we go ahead and incorporate some of the elements that we need in the model to run a perfect information case, let me just walk you through some of the updates I did. So I updated the risk profile here. So this is the economics. And I have captured and stored the reference case over here. So in the chart data, all I did was to copy the economic distribution and hard-coded the data in here, and then link that together with the live case in blue here in this chart. So in order to incorporate the perfect information into the model, we first need to make perfect information a choice in the information decision. So I'll type in perfect over here and then validate in a dropdown that this is captured. the next thing I want to do is then to create a uniform distribution on the indicator sampling here. So simply I can go to SITMAT here and create a uniform distribution. And this is now updated. So what this sampling of the indicator does is it looks up into the reality and the random variable here, and then it locates the right cell for the probabilities in order to come up with the indicator case. So we have now the sampling of reality and the sampling of the indicator. The next thing I've done here is to incorporate a reliability matrix for the perfect information. So in the rows here, you have the minor, small, mid, and large realities. And then in the columns, we have the information. So you can see now that we have perfect information reflected in this reliability matrix.
Trygve, can you explain again what perfect information is?
Sure. So perfect information. So let's go up here and explain. So you see the resource scenarios here. So perfect information will give you information that would indicate which of these scenarios that you are on, and then allows you to make a decision point. So that implies that you can change your decision. And again, we learned from earlier that changing your decision can affect the value of that information that you're assessing. So it helps you to optimize your decision policy with perfect information on the reality uncertainty. So the other thing I would say about perfect information is that you always should do a perfect information before you go ahead with anything imperfect, because perfect information is the maximum value that we will get from the information. And typically here we do it with no cost as well. So in real life, information is seldom free. Sometimes, often you have to pay for that. So you need to take into account the cost of the information, also the reliabilities of the information. The accuracy of that information is less than perfect. So this is the optimum value that we can get. So now that we've incorporated the 3 elements of perfect information into the model, let's see if we can run the perfect information economics here. So now I switched the perfect information on, and you see the value here is still 33. And the reason for that is, if we go down to this section down below here, whenever this is not no, and we're actually using information, we're not using this development decision anymore. We're using these 4 here, these reality uncertainties of the reservoir. So in this case, we're developing in all 4, which is the same as we did for no information. That's why the value is the same. So if we now want to play with this to explore what the optimum decision policy is, let's see if we got indication that the reservoir was minor, let's not develop that and see what happened to the value. So you can see now the value went from 33 up to 236. So there was huge value in avoiding the minor reservoir. So let's continue to see what happens if we choose not to develop, if we see a small reservoir as well. So now it increased slightly a bit. So it increased to 240. So it's increased the value by not developing the small curve as well as the minor. So let's continue to see, what if we only develop large? Would that increase the value? Oh, so now it dropped. So it dropped from 240 down to 145 here. So we have now explored what the optimum decision policy is with perfect information. And it seems like that's developing mid and large resource scenarios, but avoiding minor and small at 240. So Elizabeth, does this make sense to you, this curve?
So I've got a question about that. If this is perfect information, why is there still that downside on the left-hand side?
Oh, this part here?
Yes.
Well, so that's a good question. So even though we would have perfect information on the resource scenario here, remember, we will not have any indication on oil price or capital. So we're not, this just the resource parts. And you can see from the develop curves here, when we develop the mid and large, that we do have some negative sides, negative outcomes here.
Okay.
So I would expect actually to see some negative outcomes on this one as well.
All right.
Yeah. The vertical part of the curve, however, is reflecting the probabilities of not developing minor and small, and that was 50% of the time, like 40% on minor and 10% on small. So minor and small. So that's this part here. So the next thing we wanted to do now is to create the VOI distribution, and the VOI distribution is then the delta between the blue curve, the dashed blue curve, and this green curve reference case. So when you do this discretely in a tree, you would typically take 240 minus 33 here to get your expected value VOI. But we're going to take the entire distribution, and I'll show you how we do that. So the first thing we want to do is to set the model back to no information, the reference case. And I'm going into PM table here, and I'm going to copy these values and store them over here. So these are not hard-coded and not part of the data tables being calculated. Then I'm going to take the minus the live case. So the live case minus the index of this reference case that I had here. And then I'm going to take the PM index for the position. So now in this case, the VOI is now being calculated. But what we also want to do is to create an output for this. So I'm going to define the output here. And then I'm going to chart this as well. Okay, so we see here, here's the VOI distribution. And this is now saying 0, because now, remember, I put it back to the reference case. So if we now put the perfect information here, we now see the delta between these two curves. So the VOI is here 207, which is the average, which is the delta between these two, but you also see the entire curve here. So this curve here does this make sense to you, Elizabeth, now? Or do you want me to explain a little bit what goes on here?
Yeah, if you could explain a bit more.
So you can see here in this chart that they're overlapping. So up here, you're developing large and you're developing mid, and they are the same. The reference case and perfect information is the same. So if you take the delta between those two, you will get 0.
Right.
So 0 is then reflected by this part here. So actually here, versus this case, this is reflecting you don't develop. But in this case, the vertical line reflects the times you do develop the same as the reference case, because then you're the same. So the other part here is the positive part. So that's when you are able to do your mitigating risk here, where you're developing minor and small, but in reality here, with perfect information, you're avoiding developing the minor and small. So the positive side here is all related to this portion of the curve when you're doing better performance than the reference case. So what I will do now is to take the average of the distribution, the VOI distribution here, and I will copy the decision policies and the value over to our record, capture perfect. And with that, let's go over to the imperfect part. So when we input the information for the imperfect core case, we will do essentially the same thing we did for perfect. So I will start here with capturing the decision, the information decision option for doing a core. Then Elizabeth has provided me with the core cost, the min, mode, and max. So what I will quickly do is just to create a distribution around that. And then we would need to reflect the reliabilities for the imperfect case. So remember, this is not going to look like the perfect matrix, reliability matrix we have here. So last week we had a workshop at Polar Oil, and Elizabeth, you were there and you captured some of the outcome from that assessment.
Right. So for the first line, we can go right across. It's 70, 15, 10, and 5.
Okay, so for the small reality?
It's 15, 60, 23, and 2.
For mid?
It's 5, 20, 60, and 15.
And large?
2, 12, 16, and 70.
Okay, so slightly more reliable when you have minor, when you see minor or large than on the small and mid there.
That's correct, yes.
Okay. So I'll double check that we have this formula working. So we captured it correctly here. So now let's go up and test for the optimal decision policy with imperfect information. And this is for the core. So I'll start with developing all first and then select core. So here we can see the core data in the blue dotted dashed line, and then we have the reference case in green, and I added the perfect information here. So -75, so let's look at what if we develop only in small, mid, and large, so not when we see indication of minor. So we see there's some risk we have avoided here, and the expected value went up to 51. So let's try again and not develop small to see how that looks like. So we're now up to 62. Okay, try one more. So develop only in large, and we're back to 0. So looks like our optimum decision policy is developed when we get indication of mid and large for the imperfect information of the core data.
Okay. So Trygve,
Yes.
I see that the whole curve is almost the same on the risk profile, but just shifted to the left. Is that because of the cost of the well, the 132 million?
Yes, so the shift is because of the cost and also a weaker reliability. So there's two things that plays in there. So this vertical part is all due to the cost because we don't develop here imperfect and we don't develop here in imperfect. But the other parts is the cost and the reliabilities.
Okay.
Yeah. So let's look a little bit into this curve here. So we have a section here where we go negative, and we have a section here where we go positive. So those two are when we develop mid and large. And there's some false indication here too. So we may think we are developing in mid and large, but since the information is not perfect, we may actually end up on minor or small. So that's causing some of this downside here too.
Okay.
So let's look at the imperfect information VOI distribution. So I will remove the perfect. So we only look at the imperfect here. So you see the delta between 62 and 33 is 29. So this curve here, again, like the perfect, represents the difference between the blue and the green curve here. So what happens here in the, so let's start with the vertical section. So in the vertical section here, first of all, it's shifted to the left of 0, which indicate the cost. And this part is not completely vertical. It has some angle to it that reflects the uncertainty in the cost estimate that we have. So this part is when we do develop the same as the reference case. So we're developing in mid and large, and reality is mid and large.
Okay.
We get the same result except for the cost of the well. This part of the curve here is when we're doing, our outcome is better than in the reference case. So remember that we don't develop in small and minor. So in the orange curve and the gray curve here, we avoid develop, but sometimes we actually end up in those realities anyway, right?
Yes.
But the positive section of the VOI here indicates the time then when we are negative in the reference case. So you remember on the develop only that these curves here had some, the orange, the minor here had some significant downside, and this gray had some downside as well. And the times we avoid those bad outcomes is a positive for the VOI distribution because it's the incremental between the two cases.
Okay.
So that represents this part here.
Okay.
What's also worth mentioning is that we also have a large negative, although small probability. And that comes from the time when we actually are positive on the small and minor. So remember, when we're doing the same thing as reference, we have a vertical line almost. But the times we avoid developing in small and minor, some part of it is positive and some is negative. So both of those sides are reflected in this VOI distribution. So these times here is then we think we are on a mid and large curve, and we actually are on small and minor. And they are positive in the reference case. So essentially, you will get that part of the curve that you see here.
Okay. So
what we'll do is we capture the decision policy and the expected value for the core. So next, we will go in and conduct the value of information of the imperfect production test. Okay, so we'll go down here and put the production test as an option for the information decision again. And then Elizabeth, you have some cost estimate for the appraisal?
I do.
Production test?
Yes, it's 109, 131, and 177. Okay.
And for the reliabilities that we had last week, for the PT, let me just update this. So this, we'll call this core, and then PT here. Okay.
Okay, so
for the
across
minor
the line, yep. It's 85, 10, 3, and 2.
For the small?
875, 15, and 2.
And the mid?
Is 2, 8, 80, and 10.
And large?
2, 3, 10, and 85.
Okay, 85. Okay, so same thing here. As with the core, a little bit more reliable when there's the minor or the large, the extremes then.
Yes.
Okay, so I'll incorporate this part. Okay, so let's go up and test the optimal decision policy for the production test. So we have it, so 106 is this one. Okay.
Okay, okay.
Good. And then not develop in minor, when we see minor, we're at 56.
56, okay.
So you can see this, quite a bit to go on here, okay.
Mm-hmm.
And then develop only in mid and large. So we're at 69.
Okay.
See if there's any different decision policy for this test. -4, okay.
Okay.
So the mid contributes to a large part of the economics here. So this is now the optimum decision policy for the production test. And you can see there's following the kind of the same, let me do this, Excel is sometimes a little bit, doesn't like this shifting. So you can see here pretty much the same shape as the core. So you would expect with the economics and the cost of the test. So it's a little bit more expensive, but also a little bit more reliable. So the question becomes, okay, is it worth paying a little bit more money for that extra reliability that we get from the production test? So let me put back on the core here, Elizabeth, so you can compare the two curves.
Okay.
So this one here is the production test, and the yellow is the core, the 29.
Okay.
So
well,
you have go ahead.
I mean, it's really hard to distinguish. The curves are on top of each other, right? So it's hard to distinguish which one's best. Yeah. But when I'm looking at the data here at the bottom, 36 is the production test, right? And 29 is the core.
Yes.
So that shows me that the production test is the better bet for us, just based on these numbers.
Right. So maybe what we can try and do to create, maybe we can try and create the incremental curve between these two and see if it's easier for you to make a decision based on that curve.
Okay.
So what I'll do first, I'll just capture the decision policy here. Okay, so we have captured the production test both in the risk profile and the VOI distribution. So now I will go and set the model back to the core. And I will go to the PM table. And I will capture the VOI distribution and store it over here. I will then create a new name here for SIPMAT. It's going to be incremental VOI. And I will take the delta between the core, or whatever is active, live, and the core. So here's the incremental VOI curve, and this represents the difference between the production test VOI distribution, the orange curve here, and the yellow core test. So you can see that the expected value is the average is the same, 7 versus 30, and then 36 minus 29 is 7. But you now see the entire distribution around that 7. So based on this, Elizabeth, how do you feel about this decision now?
So explain to me the percentages, if you could.
Sure. So this indicates that it's 90% chance that you will have a value less than 0. So all of this upside, this average of 7 is much contributed to this, the 10% of the time that you actually gain from doing the production test. So, and this is because of the higher reliabilities that we see, including the costs, obviously, here.
Well, I mean, based on this curve, I mean, if I only had the data on the VOI distribution, I would clearly go with the production test. But now that I've seen this curve, it just makes it obvious that I'll go with the core. I just think it's too risky to go with the production test. So, yeah.
Okay. So with your recommendation now, and your risk attitude, you feel this is too risky, and you will rather settle with the core for this case.
That's correct, yes.
Okay. So with that, I will summarize the findings, and I will thank you, Elizabeth, for taking part in this exercise. And I think this was an interesting study, and it was good to have you on board on this case study. So thank you.
Thanks so much, Trygve. I appreciate it.
So let's summarize some of the results we had from our VOI's case study. So it started out with 4 scenarios, our reality and certainty, that we honored and did not alter during the VOI study. We were able to get information that would inform us on where we potentially could be on these resource scenarios. First, we established the reference case. The subsurface advisor was okay with moving ahead with the development with no further information due to the economics and some other decision criteria. The other alternative would be to leave the asset with zero pay. We then saw there was value in perfect information, and the decision policy was developing when we saw indication of large and mid. The positive values from the risk profile comes from developing in mid and large resource scenarios. The vertical part indicates we do not develop in minor and small. The negative side of the perfect information curve is when we develop mid and large, but we end up with low oil price, high development cost, and less favorable economics. We then calculated the VOI distribution by taking the perfect information minus the reference case curve. We further saw that avoiding developing minor and small led to a positive VOI distribution. These were the part of the distribution when minor and small are negative. The vertical part indicated the times we develop the same as the reference case, the mid and large cases. The negative side here is when we don't develop minor and small, but the scenarios are positive in the reference case. We then tested the appraisal well with a core test and decided that the decision policy was developed when we see indication of large and mid. We saw the reflection of this value in the risk profile. So the vertical section of this curve is when we drill a well and we take a core test and we decide based on this not to develop minor and small. The negative part is when we develop mid and large, but end up with suboptimal economics. We again took the VOI distribution by taking the appraisal imperfect curve for core minus the reference case. And we saw here that avoiding develop minor and small, part of the distribution when the minor and small are negative, contribute to a positive value. We also saw that when we develop the same as the reference case, plus adding the cost of the well, we'll have a vertical section slightly shifted to the left of the zero line. The negative part of this curve comes from when we don't develop the minor and small, but these scenarios are positive in the reference case. There's also some false indications on this part of the curve. That may, for instance, be when we think we are minor or small, that we are on a minor or small resource scenario, but they actually end up being on mid or large. We further assessed the appraisal well with a production test and decided that the optimum decision policy was large and mid. Here as well, when we develop that, we have a positive value on the risk profile. The vertical section represents where we don't develop if we get indication that we are on a minor or small. The negative part of this curve is when we develop mid and large and end up with low resources, low oil price, or high development cost. Again, we calculated the VOI distribution by taking the appraisal well minus the reference case. And we saw that avoiding developing minor and small led to a positive VOI distribution. Again, the vertical section of this curve is when we develop the same as the reference case, plus the cost of the well and the production test. The negative tail of this curve is when we don't develop minor and small, but these scenarios are positive in the reference case, plus the false indication due to the reliabilities. Without calculating the VUI distribution, as you see here, the decision maker will probably end up with the production test. However, by calculating the incremental VUI distribution here, the decision maker felt it was too risky to continue with the production test and then stayed at the option to only do a core. So continuous variables gives insights to a VUI analysis. As we saw, it led to a change in decision policy when comparing to EV decision criteria only. It helps us quantify and realize the risk of losing value when buying additional information over an entire distribution. It helps us interrogate what causes downside and explore ways to mitigate it. It can also help us understand when information is not contributing to value and why. It's also easy and instant to update reliabilities to explore sensitivities around the information accuracy. So this is also an approach to utilize simulations in risk and decision modeling. It helps us include more uncertainties and may then increase the commitment to action among the team or stakeholders. It triggers some deeper understanding of decisions, and it contributes to improving the overall decision quality. I thank you for contributing to the risk awareness and decision making, and I hope this presentation gave some ideas in terms of using continuous variables when conducting VUI studies. Thank you.